which is upload. So I've created my TeX document, and I might have created it using TeX Live, and I might have created it using TeX Live with an update that has been specially made for me because I've discovered a bug and somebody's been kind enough to fix it in time for me. That happens. So I do say that somewhere there's a big store repository that contains most of what most people need. And that should be archived and assumed to be freely available. So suppose I want to create a portable TeX document. Well, the first thing is I have to be for this scenario, you have to be a GitHub user, but you don't have to be a particularly sophisticated GitHub user. Scripts could do everything. With GitHub, you can clone you can fork a repository. And that's very interesting because it's essentially a zero cost operation, even if the repository's got 3 gigabytes of data in it. Because all you've done is you've said, I want it to look the same, and if you need anything, just ask the other person. It's a bit like the young boy who simultaneously played 2 grandmasters at chess and was guaranteed to come out at least level. In other words, he'd draw with both, or he'd beat one and defeat the other. And all he did was, when the one grandmaster was playing white and the other was playing black, and whenever the white grandmaster moved, he would copy that move over to the other grandmaster and vice versa. So he was just a dumb intermediary. And that's what's happening when you fork. You've just got a dumb copy of that repository, and only the changes that take place are mentioned. So I fork that big repository, and I check into my fork. Sorry, I go back. I put my project in it, all the files that I used for my portable document, I put into a Git repository as a commit. And it might be quite big, but they're already stored. And you can, and with Git, you say, if a document appears in the backing store, don't bother storing it, rely on the backing store. So all the files that are already in the backing store are not stored a second time. All that's stored is a reference to them. And to cut a long story short, what happens is that you've then in a position where you can push your portable TeX document to get to your fork of the big repository. And everything you need, if you've done things correctly, is there. And the bandwidth required is quite small, because if you need this big file and it's already in the destination, you don't need to transfer it. All you have to say is, I need this big file. This is what happens. This is the conversation the 2 Git repositories has. I want to push something to you, which includes this big file. And the other repositories, that's fine. Send it to me, but don't bother sending the big file. I've got it already. So that's pushing to your local repository on GitHub, and anybody from that anybody else can, from that repository, get your portable document. And again, if they've got all the sort of common stuff already installed, they don't need to fetch it. And if they haven't, then they just fetch what they need, and you set things up so that the stuff that they need is put into their backing store. Something like that will work. And so it's I read a autobiography of Eve Glennie, the percussionist, and she had an international career, and she would have musical instruments cached around the globe so that she could give concerts. because she had an enormous repertoire of specialist musical instruments. So in a similar way, all tech users will have cached on their machine core resources. And for Don Knuth, it was the core resource was the computer modern fonts. So those would exist everywhere. You could assume that every tech user would have them. And you could assume that every community, every particular community of practice would have all the common shared resources. And so the swapping of the documents would be, here's the document, here's the dependency list. You'll find you've got almost everything you need. And the stuff that you don't get, you can get from my repository. Now, at that point, you do need the internet to get the stuff from my repository, but you needed the internet to get the document from me in the first place. So you haven't really lost very much. You've lost something that you've already lost. This might be a bit hard to believe or understand if you've not used Git before. I'm using that to use proof by authority. I think that's what it's called.
So I've got, I guess, some questions. So if TeX Live 2021 was just the state at a certain time in a Git repository, and that state is inviolable, you can't go back and change it. You can only add things after that. Then if I write a document, all I have to do is say that this was based on TeX 2021, TeX Live 2021. And if I change anything, then I'm obligated to include that with my document. But the only hash you really need is the hash for TeX Live 2021.
Yeah, I got it pretty much there.
Okay.
If I write my document and somehow it triggers a bug in article.sty, I will fix that bug so I can complete my document. And then the secure hashes for my document have got an unknown, or rather, I'm the only one that knows it. And of course, nobody else can reproduce my document unless they can have that unknown. So there's an onus on me to make that unknown available.
Mm-hmm.
And on the other hand, the fact that that unknown exists should be very quickly discoverable, because it's not on the list of all the magic hashes. So upon receipt, I can say, well, I don't have this. Where do I get it from? You didn't tell me where.
Yeah, well,
Get it from.
One possibility is I could just check it into Git.
Yeah.
As a branch.
Yeah.
And then in 2022, somebody has to decide of the 1,000 branches of this particular file, which one gets carried through to be part of the core of the TeX Live 2022. So a whole bunch of branches will get abandoned, but the files will still be there so that my document can be compiled correctly.
Yeah. Actually, the problem is exactly the same as with your TeX source document that contains your proof of the Riemann hypothesis, if that's what you've written.
Yeah.
That you can send the secure hash, but the document can't be compiled until the secure hash can be instantiated. And because you created that secure hash by creating a document, you have a responsibility to make that secure hash available. If I produce a software package and put it up on GitHub and say, there it is, it's wonderful, and then I decide that it's not wonderful and that it's embarrassing to me and delete it, all the secure hashes disappear unless somebody's taken care of them. So if you care about your resource, you might, in collaboration with others, ensure that it persists. So yeah. If heaven forbid, well, if GitHub, for example, if you don't completely trust GitHub, then you should provide an you should put copies of everything you need somewhere else that you do trust. And this is the old thing of important documents reproduced in triplicate. The thing that I'm doing is I'm saying, here's a mechanism for distributing these things and communicating these things, and knowing that you've got the same object without having to do a byte by byte comparison over gigabytes. You both do a calculation on your own trees and you both come up with the same results, and you say, right, that guarantees we've got the same inputs. In my notice of this meeting, I said that TeX produces the same outputs from the same inputs. And so the problem is to guarantee that you get the same inputs. And Git solves that by computing a secure hash.
Right.
And it allows you to economically transfer exactly what you need.
Well, yeah, if I make changes in a package, I could send it to Git and put it on a new branch.
Yeah.
And then my document would say, to compile this, you need to use such and such a branch.
Well, you need to do two things. The first thing you have is that you have to give the human name of the branch.
Yeah.
And the other thing you have to do is you have to give the, so to speak, the Gitish secure hash name of the branch, because the human name of the branch can easily be forged, whereas the Gitish name of the branch can't be forged. But essentially, you've got the right idea there, Barry.
Yeah.
I'm just being tricky on details.
And then if my changes are not desired for the next TeX Live, my branch just gets abandoned, but it's still there.
Yeah.
So that my file can always be compiled.
Yeah, and because it's your clone, even if the original disappears, everything that you cloned is still available on GitHub.
Yeah, but some person 20 years from now, after I'm dead, wants to compile this file. They won't be able to do it unless it's on the standard CTAN.
Well, they might have great difficulty finding the exact secure hash they're needing. There's a story by Jean-Louis Borges of a library that contains every possible book in the world. Vast. And people are searching this library for the one special book that is the key to the library. It tells you where the good stuff is. And searching the GitHub repositories blind without some indication of social indications of value is like that. But that's exactly the development process that happens with Linux, that all this stuff is forked and goes through all sorts of processes, and then it goes into the official Linux kernel. And then after it's gone into the official Linux kernel, all the people do their own special things with it because they feel like doing it or they've got special needs. And one of the things about Git is that forking is very cheap. Merging is very cheap. I mean, you can make it expensive if you're careless, but in principle, these things. It seems that you're quite familiar with Git, Barry.
I'm more familiar with Mercurial, but all of them are pretty much the same.
At this level, certainly, yes.
Yeah.
Yeah, I prefer Mercurial because I'm a Python person, but I think Git has won out because of its efficiency as a file system. So we're almost at the end and we're only 15 minutes over time.